Hey guys, today we're going to be using something called to solve problems related to gas pressure and changes in all these factors that affect gas pressure. So here's the situation we're looking at. This will probably look familiar. Gas in a can of spray paint is at 3.5 atmospheres when the temperature is at 293 Kelvin. If the temperature increases to 323 Kelvin, what happens to the pressure and what will the new pressure be? So in order to do this, we are going to create this thing that we call an IFE chart. And so let's take that piece by piece and see what that means. So IFE across the side, and then in this order, it's important that you put it in this order, the different variables that we're looking at. Pressure, volume, the amount of gas, which we use N for, and the temperature. And we're just going to create a chart with these. Just like that. And so anytime we have a problem like this where we have changes in all these factors, we can use this chart. Now, what do these stand for? The I stands for initial, or what is it at the start. F stands for final, or what it is at the end, and E stands for effect. That is, how is it going to change? Usually we're looking at pressure, but it could be whatever. So what we've got to do is we look for conditions for each of these. So let's start with pressure. The first thing we're looking for is our initial pressure. So we read through the problem and see, do we have an initial pressure? Well, the gas in the can of spray paint is at 3.5 atmosphere when the temperature is at 293 Kelvin. That's where we started. So the pressure started at 3.5. Now, what is the final pressure rather? Well, we don't know. What will the new pressure be? That's what we're looking for. And so we put a question mark in that area for the thing that we want to find. All right, now we look at volume. And notice that this problem doesn't give us any information about volume. If you're not given any information about volume, you can assume that the volume stays constant. That is, it doesn't change. So what I can do is I can just put a line there. I don't have to worry about it. Amount of gas, well, reading through the problem, the amount of gas doesn't change, so I don't have to worry about it. Temperature. Our starting temperature, if we read through, was 293 Kelvin. Temperature for this has to be in Kelvin. Don't use Celsius for this. It's going to, well, I should say it'll work just fine as long as the numbers are positive. However, if you start to get negative numbers, that's going to really mess with this process. So we use the Kelvin scale where we don't have any negative numbers. And our final temperature, well, the temperature goes up to 323 Kelvin. So now we're going to talk about the effect. That is, what effect does this have on our pressure? And this chart is kind of nice, specifically if you set it up like this, P, V, N, and T, because we can draw a line sort of smack dab through the middle of this thing. Things on opposite side of this line, if one goes up, that goes up. So for instance, temperature and pressure are on opposite sides of this line. So if the temperature goes up, the effect on the pressure is that it goes up as well. If the amount of gas goes up, it's on the opposite side of this pressure, so the amount of gas going up will increase the pressure. Same thing for volume. If we were looking for how this affects the volume, volume and amount of gas are on opposite sides, so if the amount of gas goes up, the amount of volume goes up. Now if they're on the same side, then they're going to have an opposite relationship. So for instance, if these two are held constant, we don't look at them. If the amount of gas goes up, the temperature is going to go down. That's probably a weird example because you never really see that much in real life, but it works very nicely when we look at pressure and volume. That is, if we increase the pressure, the volume is going to go down, or if we, there are opposites, so whatever happens to one. Now, going back to this, we want to know the effect that the temperature is going to have on the pressure. Well, the temperature went up, so the effect is that it's going to go up. Just like that. And what I've done here is, actually, let's not do that. Let's just put it over here with the thing we're interested in. So the net effect is that the pressure is going to go up from that. So again, here the temperature went up. They're on opposite sides of that middle line, so the pressure is going to go up as well. So I draw an up arrow here, showing that the effect is that we're going to increase the pressure. Whatever value we end up finding for the pressure, it should be bigger than 3.5. Now let's talk about how to actually find that. So what I'm going to do is I take whatever value I have, my initial value where I'm wanting to find the final value, and I just write that down, 3.5. And then I'm going to do a conversion factor, just like I did when converting with pressure, only now what I'm going to do instead is I'm going to use the numbers from over here to put into this. And here's the way I figure this out. I know that pressure is going to go up. So I want the bigger of these two to be on top. So 323 goes in the top, 293 goes in the bottom. And when I multiply that out, what I'm going to get is my new pressure, and that new pressure is going to be, sorry, I lost my train of thought there. That new pressure is going to be due to the change in temperature, and all I have to do is multiply that through. Again, this is just like we did with the changing of the pressure units. And so I find that my new pressure is going to be 3.9, if I'm using sig figs, 3.9 atmosphere. So again, what I did was I built this chart. I established how this change in temperature is going to affect the pressure. It's going to cause it to go up. Then I take my initial pressure value and I multiply it by a conversion factor made from these two temperature values. Since I wanted this to get bigger, I put the bigger temperature value on top. If I wanted this to get smaller, all I'd have to do is reverse these and put the bigger one on bottom, and then multiply through, and I get my new pressure. And this can work for any kind of problem where you're dealing with changes in these. This chart is very, very handy. Also, we can do this if we have multiple changes, like if we had the temperature changed and the volume changed. All you would have to do is add another conversion factor here to the end, and I will ask you to do that on a couple problems later. And again, if you have any questions, just let me know.